All right. So to define unit tests, which is a necessary evil to get started, it's a piece of code that verifies and confirms the functionality of a small unit of code. So the key characteristic of unit tests, they should be really fast to execute, and they should be able to run on every developer machine with very little or in fact no configuration changes that need to be required. Okay. So with unit tests being defined, it's like a piece of code that verifies and confirms, right? So more often than not, when delving into test-driven development, there is always this very fine line and question that people ask me: what is the difference between unit tests versus integration tests? How do I test my entire software to make sure all the parts fit together, right? So that's called integration testing. So once you test your small pieces of code, then to make sure it all fits together, we make sure we have integration tests. There is nothing wrong in using unit testing frameworks for integration testing, but it's just it is ideal that you separate those integration tests from your unit tests, because another key characteristic of unit tests is they should be really fast to execute. Like you can run it test suite and it should be really fast. So adding integration tests uh, delays the project, so you would ideally want to uh, separate your integration tests. All right. So what is an expectation from this session? I'll make sure that you guys are all an expert in this workflow. Okay, everybody with me on that? All right, that was just a joke. All right, maybe this slide is too boring, so let's go ahead and look at a more colorful slide. All right, so the key terminology in test development is red, green, and refactor. Okay, so what does that red, green, refactor mean? So the idea is you start by writing some failing test cases, and then you make them pass those test cases, and then you constantly refactor your code until it meets your team's code quality metrics. And there are cases where it fails back and you make them pass. So it's a cycle, right? As long as you meet your quality of the code metrics, you're good, right? So with that being said, now we all understand red green refactor. um, let's understand what kind of scenarios that we run into. Typically it's just two cases, right? One is testing, how do I implement test cases for my legacy code? Because whenever you change some code, it is very important that you always write your test cases against your legacy code. More often than not, you'll be stuck with it, right? So let's take a quick. Oh god, that felt like somebody hit a hammer on my head. So I'll show you a code very similar to that. All right. All right. Why is can anybody just say they can hear everything pretty well? Okay, good. So this is a piece of code. Let's assume this is legacy code. Some non-experienced guy who doesn't care about coding. That was just me. Wrote it about like 15 years ago. All right. So the concept of this code is it's like a credit. It's a credit class, and when you post a credit for a billing amount which is an integer, yeah, great, right? So and every time the billing amount is greater than $1,000, it just says send an email to someone, right? So that's a code. So this is a legacy code. How do I write my test cases against that, right? So let's go ahead and get started. So what I in this project in this demo, I'm using Microsoft MS Tests to write some test cases and show you some live samples. Okay, so I created a credit class just to get a little bit ahead, and let's do credit dot post credit and say $100. And so if you're using MS Test, then you would want to use your Test Explorer. Oh, you need to compile your application again. Right after that, all right, so that's compiling. All right, so there comes our test case. Let's right click on it and debug through the circuit test case in this specific case. So to debug, you need to put a breakpoint. So let's go ahead and write a test case here, right? So the billing amount is greater than 1,000. So, but we need to write a failing test case, right? So let's write a test case that takes in that amount. Some credit, some department wants to give a credit. So let's go ahead and right click on it. That's going to blow up. Great. So we started with a red, right? So how do I separate this? The first thing that I'm going to do is change this to decimal. Okay, because technically amount should be a decimal. That's how I go back and keep refactoring my code. All right, still failing. Great. Now what I'm going to do is let's do some more refactoring, right? So let's say it is not necessary that you would want to keep sending emails. Probably tomorrow you may want to send fax, tomorrow you may want to send SMS or some other messaging pattern, right? So let's go ahead and refactor this part of the code, right? Extract method, send notification. All right, I hate static methods, so I'm just going to delete that because static methods are not really testable. All right, let's go ahead and rerun our test case. All right, so it failed again. In this case, to make it pass, we'll just say message sent, or you know what? Then we need to do a little bit more, right? So let's take this method and create a new class. Communication, sorry, communication. And then I'm going to call public. All right. Please bear with me for just a couple more minutes, okay? And make sure ecom dot send notification. In this case, for now, let's comment it out, right? Let's make sure at least the test passes once. All right, it passed. So as long as it's coming into this, it's going to pass the test case. So it's really hard to verify this void cases, right? So then I would want to extract an interface from it. And then communication. All right. So in this specific case, all I'm doing is just trying to extract an interface and pass that as a dependency here, right? And then we can really start testing the way it should be. You see how quickly this code is changing, right? Right? And then instead of this, I'm just going to say and then I'm going to say this. In this specific case, since I don't have an IOC container, I'm just going to hard code it for now and say email communication. If is equal to null, then I'm going to say, all right. So all I'm trying to show you guys is make your code testable, right? So if this was always going to call an email notification, then it's very difficult for me to test my create my unit test because it'll always require an SMTP server, right? You guys see my point? I'm just trying to avoid any external dependencies, and I'm just trying to make sure that logic that I'm going to call is going to always be testable. Let's say now in this specific case, see our test case is going to fail, and let's create a new implementation from it, right? Let's create a dummy implementation, dummy email sender, and it's going to implement iCommunication. All right. In this case, this is more on my test cases side, right? I'm just going to send this dummy email communication. And now my code is just going to work fine. So email communication still depends on SMTP server, but when I'm testing my code, I don't always have to call my email communication class. It could be whatever I send it as a dependency. Okay? As long as I'm sending in a dependency which I can test, we are fine. So let's go ahead and debug this again, right? All right, looks like something failed. All right, so let's go ahead and implement interface here and say let's not throw an exception. That could be one way to test, right? What happens if something if an exception is thrown? So you do nothing. Successfully sent. All right, let's debug. It goes in here. It sees it's greater than $1,000 and it sends a communication and nothing is broken. You see that, right? All right. So it's all about creating some external dependencies and making your test cases super fast, and you always make sure your logic is tested, right? So let's come back to the slides and learn what are some techniques for creating some test doubles or creating some test dependencies. How do you make sure a send communication method in email is being called, yada yada. Okay, any questions so far? You are 17 minutes into it, so if any questions, this may be a good time before we move on to the next chapter. All right, silence is good in this case. All right. So for the refactor part of it, what are some common code smells that you need to take a look at, right? So when you see duplicated code, that's when you know you need to refactor that. You see some long methods being in your method. If your methods are too long, then you know you need to refactor. If you are using too many primitive types as your input parameters, then yes. Believe it or not, a switch statement is one of those. There was this early phase in my life where I was writing switch statements all over the code. Yeah, too bad. I fixed myself though. So there is a long parameter list, obviously, and there is a large class with a lot of methods. And too many comments. If you write too many comments, then there is something wrong with your code because you're trying to explain uh, a developer. If you're trying to explain a developer the code you're trying to write, that means there is something wrong. Your method name should be so clean that they should be self-revealing. Your code should be so well separated, like the single responsibility, all these solid principles, that you shouldn't really need to have comments other than to say, okay, this could be implemented or called by. Okay, and the conditional complexity. So if you all have seen a lot of ifs and else, nested ifs, nested elses, then that's where your complexity of the code is increasing. So that's really bad. Like if you have too many nested ifs, then something is really wrong. You need to go fix that. Um, Again, the bad naming conventions, which are a result of those comments, and dead code. How many of you have seen dead code? Probably everyone, right? So we need to get rid of the dead code. Uh, yeah, in like 100 years from now, we may do this. So I'm going to leave that code in. Yeah, don't do it. It's really a bad idea. If you are not using some code, it's very unlikely somebody's going to come back and use it like 10 years later. All right. So with that being said, that's one part of the refactoring. So I was previously talking about these dependencies, right? Like calling an email, calling a database, and all that other stuff. So there's something called test doubles in test-driven development. It's a concept, right? So it's something that looks like an original object that a system under test depends. If you have looked at my previous, if I have to refer to my previous code that I've written, um, the external dependency that I had in that case was sending an email, right? All right. So let's go talk about some of these ingredients of test doubles, okay? And we'll look at some code, which is generic. It doesn't matter if you are Java, you are C sharp, it doesn't matter. It's generic code concepts. So there are cases where you send in some input values to test your code, right? So that's called dummies. You're simulating some value. Simulating some values and making sure it's the same. You're getting an expected result on it. So that's something called dummies. So in this case, there is an order object that I'm instantiating, and I'm sending the values 12 and 1, and it probably should return 13. And like I said, if I have to start by writing failing test cases, I'm just going to say number of line items are 2 or 3 or whatever that is. Okay, that's called dummies. So let's move on to stubs. What is a stub? Stub is a fake implementation. It's not like a real implementation. If you have looked at my previous example here, my bad. I really did not want that. So if you look at my so the dummy implementation that I stubbed out, that's called a stub. So whenever you need something implemented, that's called a stub. So let's move on to the next ingredients. So there's something called fakes, just like the ones you see here, like the fake teeth. So you can create your own fake implementation, right? So let's say if I have to simulate a student repository, right? Like a student database. Repository in this sense is more like a database. So if somebody is wanting to talk to a student database or student table, then obviously you'll need those CRUD methods, right? The save, update, create, read, update, delete. In this case, I just implemented a couple of them. And I start by creating a fake list of students. And whenever somebody calls this save, I keep adding to the list, which is in memory in this case. And when I have to delete it, I just remove it from this in memory list here. So it's like a fake implementation of a student table. right? So that's called a fake. So the next thing, which is interesting, which is spies. She has some interesting stories, but I may have to move it to an happy hour or something. So let's move on to some real code uh, for spies. So what is a spy, right? In my previous example, I was trying to make a call to an email to an SMTP server to send an email, but I need to, in my test case, I don't really want to make a call to the SMTP server. I just need to make sure that method is being called. So to add, there are some variables that you could add to some classes, to which in this case, if you look at this, oh, my bad. In this case, uh, to make sure if a student show method was called or not, add a variable and set a value to true whenever this is being called. This is like a fake implementation, right? In this fake implementation, if I add a value that tells you if a method was called or not, then that's called a spy in test-driven development. All right. So these are the concepts, right? So there are some frameworks that implement these concepts. So some typical examples are mock, and there is something called RhinoMocks. So if you are from a Microsoft world, there's something called FakesFramework. So we'll demo both RhinoMocks and a FakesFramework, which is more Microsoft related, but again the same similar concept, right? I just want to simulate some ideas so that you can pick and choose whichever framework that you like. So in RhinoMocks or any mocks, there are three types of mocking, right? One is a strict mock, which is in this case, a strict mock is if you try to call a method unexpectedly, then the mock will fail verification and throw an exception. You'll understand more once I start showing some code. And in a dynamic mock, you can call a method even though there is no solid implementation for it, and the test case will not fail. And there is something called partial mock. Just try to understand the high level concept of it. You don't have to learn everything in it. As you start writing your test cases, you'll get to use these concepts. Okay. And in a partial mock, certain methods are mocked, and you will get an exception when if you try to call a method that is not implemented in your fakes. Okay. That being said, let's take a look at some code again. All right. So let me explain a little bit about the code that I want to demo you guys today. Okay. So there is this program.cs class which calls an event a billing subscriber, which listens to something called billing alert event. So what is a billing alert in my case? If the amount that I'm trying to post is greater than $100 or $1,000, whatever that is, then it throws an event and it'll be caught by subscriber. Again, it will be related to the subscriber, and the subscriber uses iCommunication as its dependency to send an email or fax or whatever that is. Okay, using a communication request. So that at a high level, that's the sample that I want you to see. Okay, so with that being said, let's take a look at the billing subscriber class. In this billing subscriber, I have a dependency of iCommunication, and if the invoice in the billing request, see in the previous example I was using POCO types, but I always suggest using a solid class. That's like after you refactor, you should always try to have a solid class so that your signature doesn't have to change. For this method, your signature doesn't have to change. So with that being said, if it's greater than $1,000, then it's going to call whatever is in the communication, send communication. And in the communication request, it could be from this phone number or email or whatever that is. Depends. You could have a generic XML class that you could serialize. But in this case, at least, I have a true or false event that I could test. Okay. So I write these test cases, right, where I expect an expectation. So let's talk about where RhinoMocks come into place. So in my situation, I have started by writing a simple account alert test class, and I have a method called get current billing subscriber, where I simulate a mock for iCommunication, which is like for sending email or sending communication. So I'm generating a mock and I'm sending it as a dependency for my test class. Okay, I'm simulating a mock for iCommunication and passing it as a dependency to whoever notifies accountants. So in this case, I'm creating a billing alerter, which is my event-based system. And for that iCommunication, if somebody calls send communication, I'm saying throw a new exception. This is all RhinoMocks, okay? This part of it, this very part of it is RhinoMocks. Like generating a mock, which is RhinoMocks dot. If you look at, all you have to do is just import this rhino.mocks and all this mock repository and how to stub out your methods. This very part of it, I think I'll have to increase the font size. Does anybody know how to increase the font size? I think it was in tools. Or you know what, I can do Control++. I wish I had a bigger font. Guys, are you able to see this font?
Yeah, we can see it.
You can see it.
Either you can zoom in.
The bottom left corner is your zoom.
Bottom left corner.
Where it says 100%. If you.
Oh, yes, yes. All right. Thank you. Thank you so much. All right. Thank you, guys. So all I'm trying to say here was you can stub out methods. We talked about stubs, right? Just a couple of seconds ago. So within the iCommunication, if somebody calls a send communication method, it doesn't matter what type of parameter that he's sending in, throw an exception, right? So let's check. So in this case, I'm just saying I'm raising an event, and it'll be obviously alert. If you go here, again it goes to an interface, but again I showed you the billing subscriber method for alert. If it is greater than $1,000, then it's going to raise an exception. Okay, so for those kind of exception handling scenarios, in this case I'm just saying 999. So assert an exception. Was that method called or not? There is something called assert was not called to make sure that the method is not called, right? There are also like plenty of things like how many times this method was called. It's like a fluent interface. You can. Right, so it's right now the interface is not giving me IntelliSense. Right. So you can always make sure the number of times the method was called or something like that, right? So let's move on to amount less than $1,000. So the way you write your test cases is, one is, since you're testing for greater than $1,000, you need 3 test cases. One is amount less than 1,000, one is equal to 1,000, and one is greater than $1,000. So in this case, let's go ahead and open the test view. Okay. So if you guys don't know how to get to the test editor, then this is how: test, Windows, and you get to the test view. So you can run these 3 test cases, right? And make sure you'll make sure they all pass. Because when I'm calling send email, it's not like really calling the send email. It's simulating it. So let me take one example and show you guys that. So all our test cases have passed, right? So let's make sure we walk through this test case. So when you double click on it, it should take you to that test case. Okay, so we have a breakpoint. So let's see what's this stubbing doing behind the scenes. debug selection, and it will go to that breakpoint that we have. All right, so we came here, and in this case we are going to get the current billing subscriber. So let's see, when generating a mock, what has it generated for us? If you look at it, it created a proxy class, and it has some interceptors and all that good stuff. And so how many times has this method been called and all that stuff. So I'm sending this to my as a dependency, and let's say right now test email is an interface implementation, right? So once we say this, it'll always return a true value, right? Regardless of what input parameters that I'm sending in, it's just going to say true. So we go here and we say amount greater than $1,000. No, it says false, because amount was less than $1,000, the send communication was not supposed to be called. You get that? So let's make sure that happened, right? Arg only. Okay, it requires more than one things. So let's go ahead and refactor that a little bit. Let's see why it has failed. It was about it. Okay, that's probably why. Right. So expected result was false, which means that there should be no alert being sent. Made sure that happened. And instead of send communication, need to make sure. There we go. So we made sure that it was not called, right? What happens if I say make sure it was being called? Okay, it should fail our test case, right? Because technically the amount is less than $1,000, and if it's less than $1,000, it's not even supposed to call the send communication. So let's test that. Debug selection. All right. Expected 1 and actual was 0. Okay. So if you let it run, we can go take a look at why it has failed. So let's go to the test view and test results. So if you look at it, so let's look at the error message here. If you look at the details of it, then it says it was expecting a 1, which is a true or false values, right? So the actual was 0 because it was not being called, right? So we have seen this part of it, right? But who has the time to write all these test cases like one at a time? Like imagine writing like hundreds of methods. As developers, we all slog through those methods, right? Who has the time to write all this? So that's why there is something called data-driven testing, where you can provide a file with your test cases, or a QA or a BA could say if it is greater than they can write their test cases, and you can tell them, hey, if the invoice amount is 1001,999, and what if it's a negative number, right? And what should be your expected test result? So you upload an Excel file or a CSV file for that case, and or where is that any amount. Then you can say, hey, my data source for that was for like a specific amount. In this specific case, you can write your test case for any amount. All you have to do is just say your input source is CSV, and this is a file name within your data directory, and that's it. You read that invoice amount header, whatever value is there, and then you read your expected result and set it to values, and you run through your test cases, right? Again, you don't want to send emails, so you're stubbing out and faking this method called send communication, which always returns true whenever it's being called. It doesn't raise an exception or anything like that. So you can run that one specific case, and you can look at it and see it runs through 3 test cases. Okay. Oh, my bad. I picked the wrong test case. It should be any amount.test. Let's run through this. All right, so 1 second. Let's give it some time to finish. So there is this any amount test, which takes in a CSV file. You can read the input from the CSV file and run through this same code for multiple test cases. So if you looked at it, so it ran 4 test cases, or 3 test cases in this case. So for data row 1, it has passed the test, and for data row 2, data row 3, right? So let's make a small change and say, let's change the test result, right? And then compile our application real quick, compile our test project real quick, and then we'll take a look at by running that specific test case. Okay, so let's run through that, and then it's going to take its own time to run. Let's take, oh, okay, I think I need to change my test case. Assert dot r equal the expected test result and the actual result. Okay, let's comment this code for a second here. Okay, has failed, and we can see that we have changed the second row, and it's saying it's expecting a true, but the actual value was false. So we go back and rerun it again. We fix it, and but you guys get the point, right? I don't want to drag too much on that specific part of it. Okay, so simple case. Again, let me repeat whatever I just covered in a bit here. So always make your code testable by refactoring and making it have dependencies as an IOC. You could use IOC container or something like that, but you should always for whenever your code depends on external sources, for instance writing to a file, writing to a database, or calling a database, or sending an email or fax, whatever that is, always take in a dependency, just like how we did in this specific case, which was, 1 second guys, so which was this. You should always take in any external things as your dependencies, and which will help you simulate these fakes and stubs. And in our case, we create a mock using a mocking repository, which is from RhinoMocks. You just create whatever interface that needs to be implemented. You generate a mock for it, and you tell it what should be the expected result if a certain method is called. Like, should it throw an exception, or should it return a true, or should it return a false, or whatever that is, right? And then you can always make sure a certain method is called, or a method was called X number of times, or whatever that is. Okay, so far so good. All right. So with that, I'll move on to a implementation of a fakes framework. Okay. For my fakes framework demo, I'm going to show you this class diagram. So I have a yeah. So with that, let me take a look at this exchange rate thing, right? It's like an exchange rate service. So we are calling an iExchange calculator, which calls an Oanda service, which is like a third-party service. And then we have to keep the response generic so that we can replace this Oanda. We have an iTransformer, which transforms the response from this external third-party Oanda and send it in the response format that we would like. Okay, so it's like an iExchange rate converter, which takes in iExchange calculator as its dependency, and this iExchange calculator takes in iTransformer, so that real page always has a standard interface that we generally have. Okay, just 1 second, guys. So in this case, let me show you some test cases that use fakes framework. So in this case, if it's a fakes framework, all you have to do is whenever you're adding a reference to a assembly or something like that, right click on it and add fakes assembly. That's how easy that is. But RhinoMocks is even better. But if you want to stick to the Microsoft stack, then that's an option, right? So you'll have to, for every reference that you want, you could add a fakes assembly, and that's going to implement your fake implementation. So in this case, I'm talking to a database, which is an IAP core database, which is an accounting database. And for that database, I'm creating a fake, and I'm saying whenever I try to call a method called check if exchange rate is current in Epicor, then I'm going to return it a true. In this case, I'm going to return it a false. So something like that. It's very similar to RhinoMocks, but it's just the syntactic aspect of it, right? So then I make a call and I stub out. So in this case, it clearly says stub iExchange rate calculator, but in RhinoMocks case, you can send in a generic. It takes a generic T, where you can send iExchange rate converter or whatever that is. Okay, so that's a little bit about Fakes framework. Uh, are there any questions? I think I pretty much covered everything that I wanted to cover, and we covered a data-driven example. Uh, hope this has given a good overview of how to get into test-driven development. Again, like I have written a lot of test cases and all that. If you need some live examples, you can always email me. And so I would like to leave this last 5 to 10 minutes for Q&As if anybody has any questions. Hello. All right. Can somebody just say something? Do they like it, or
We are good, Sridhar.
you good? All right. Thank you, folks. So again, like if you have questions, then you can always email me, and I'll send you guys this recording. All right.
Yep. Thank you.
Thank you, guys.
Thanks.